So what we got here is a real simple thing. You have to check yourself. So what you're going to do is you are going to get yourself something to write with, something to write on, and see if you can do these questions. This is covering some of the questions from 6.1, 6.2, and just make sure you're okay with some of the basic trig stuff, especially radians here. So what I would recommend for this video right now is pause the video. You can see the questions are there. Give them a shot, and then when you're ready, unpause it, and we'll see if you got everything right. In terms of rounding and all that, when you see exact value, there are no rounding rules because exact means exact. For number 2, I said solve. You can solve it exactly if possible, but if not possible, just round to a couple decimal places. Anyway, give it a shot and go. Okay, so my assumption is if you have not paused the video here, you should actually do it. I'm going to go over the answers in just a sec now. The one thing I'll ask is when you get this done, I'm not even going to ask for anything fancy. Just leave a note in the comments below that you did it. Just say done or something to that effect, and it just lets me know who's actually getting the stuff done. I noticed with my last stealthy quiz, probably less than half the class answered it, which is not real heartwarming, to be honest. I'm assuming a few more people did it and never bothered to actually do this little assignment, but please, as I'm keeping track of this stuff, get your comments in. Okay, so sine of 7 pi over 6. When you're determining the exact value, that's a good hint that you're looking for something with a special angle and a special triangle. So what I would do to answer this question is, first of all, I would do a quick little sketch. We're talking about 7 pi over 6, so there's radians. Again, because of the pi, but also because you don't see a little degree symbol up there, so that's how you really know it's radians. Pi is not necessarily included in all radian measurements, but it commonly is. So anyway, so we're starting at 0 here. Here's pi over 2. Here's pi. Here's 3 pi over 2, and then we're back to 2 pi, and so on. So 7 pi over 6 is a little bit more than 6 pi over 6. That's maybe not exactly what the angle looks like. But here's about a pi over 6 reference angle. So you're in quadrant 3, which means sine is positive. And let's see, what is the actual ratio? So the special angle triangle here is pi over 6. And this is 1, 2, root 3. So sine is opposite over hypotenuse. So what we should get is sine of 7 pi over 6 is, now it's in quadrant 3, so it's going to be negative. So we should get, I'm just moving this down, we should get negative 1 over 2, and that should be the exact value. So we are figuring out the ratio of opposite to hypotenuse, and in quadrant 3, ASTC, well, that tells us that quadrant 3 sine is negative. Okay, so there we go, there's the first answer. For the next one, cotan of negative 5 pi over 4. So let's draw a negative 5 pi over 4. Starting at the positive x-axis going in the negative direction, and we're going over here. Okay, so this gives me a reference angle of pi over 4. 5 pi over 4 is like 4 pi over 4 plus an extra pi over 4. So what we've got to do is we've got to now look at the special triangle here. This is pi over 4. And of course, cotan equals, tan is opposite over adjacent, so this is adjacent over opposite. So that is going to be 1 over 1, or just 1. Now is it positive or negative? A, S, T, C. Cotan is like tan, so it's negative in quadrant 2, so we go negative 1, and that would be our answer for that guy. Finally, secant of 7 pi. So I'm going to show you a little trick here. If you don't like an angle, you can add as many 2 pi's or subtract as many 2 pi's as you want, and you're going to get the same thing. So I'm going to subtract 2 pi, and I'm going to subtract 2 pi 3 times, or I'm going to subtract 6 pi. Turns out secant of 7 pi is the exact same thing as secant of pi. So you can always figure out a simpler coterminal angle by subtracting as many subtract 2 pi as much as you want, and that's a general rule. As much as you want. That's a general rule that you can employ in all trigonometry. You can always always add and subtract 2 pi as much as you want, or 360 degrees. So how do we make sense of secant of pi? This is where personally I would, you can draw the Cartesian coordinate grid, and you might do that, or you might draw the, you know, the wavy guy here. I personally prefer the wavy one, but I'm going to try it with this. So secant of pi looks like this. The terminal arm is laying flat. So the hypotenuse here and the adjacent side are both the same. Now the adjacent side is equal to negative and the hypotenuse is positive by definition. And then of course the opposite is equal to 0 because the triangle is laying flat. Normally when we have a triangle, this is the opposite here. But in this case, when it's laying flat, the opposite disappears. So what we can say is the secant, which remember secant is the opposite of cosine. So cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, which means that the hypotenuse and the adjacent are the same length, but one is negative and one is positive, so this is going to wind up giving us -1. Ta-da! Okay, there you go. Those are the exact values of those trig ratios. Number 2 is the more meat and potatoes here, where you've got a little something to chew on and digest. This is going to take a little longer. So let's look at how we do a question like 2a. It's cosecant theta. So the first thing I'm going to do is I got to solve for theta. I can pick up my calculator, but there's 2 issues here. One of them is I can't do cosecant on my calculator. The other issue is that when I see 2's and √3's, I actually think this must be a special triangle question. And it turns out it is. So the reference angle here, what we have to do to get the reference angle is we got to sketch somewhere, maybe off on the side, we got to sketch what kind of triangle has 2's and √3's. So we got this one here. This should come to mind. Now we're talking about cosecant, which is 1 over sine. So cosecant is 1 over sine, which is hypotenuse over opposite. Okay, that's really important that you identify that. So what that tells us is that the hypotenuse is 2 and the opposite is √3. So what angle in this triangle has that being the case? So the opposite, well, the angle for which √3 is the opposite is this guy up here, and that turns out that's pi over 3. So all this thought process has to go on in order for you to figure out what the reference angle is, and the reference angle therefore is pi over 3. Okay, so what we do is then we acknowledge that sine is positive in quadrant 1 and quadrant 2. So what we do is we then break this up into a quadrant 1 possibility and a quadrant 2 possibility. There's 2 different possibilities for where the angle is. So we say in quadrant 1, theta is equal to, sorry, I shouldn't use equal signs here, I should use colons. You should only have one equal sign in your equation. So theta is equal to the reference angle. Okay, it's very simple. When you've got quadrant 1 angle like this, if this is a reference angle of pi over 3, well, that's what theta is. When you've got in quadrant 2 a reference angle of pi over 3, now you've got to go pi minus the reference angle. And there is a short little video where I showed how you can get these formulas, which you hopefully saw. So one of them is pi over 3, which is the quadrant 1 angle, and the other one is pi minus pi over 3, which is 2 pi over 3. Cool. Okay, so those are my 2 answers. Now, if you look at the domain restriction, we can go between 0 and 4 pi, which means we can do a full rotation around. You can go 0, 2 pi, 4 pi. So we can do like a full rotation and a little extra. So we have to add in the possible answers for 1 extra rotation. So also, we're going to add 2 pi to this because we're getting another full rotation, and we can have, what's that, 7 pi over 3 as well. So the big concept in trigonometry, and this is going to keep coming up more and more, is we can always add as many 2 pi's as we need. So in this case, let's see, that's going to be 8 pi over 3. Okay, so I'm just going to write a tiny little note here. this is for coterminal angles. We can always add as many coterminal angles as we want, provided they're in the domain restriction. So finally, what is the final way of writing the answer? You would therefore say theta equals, and you can list them all, like pi over 3 comma 2 pi over 3 and 7 pi over 3 comma 8 pi over 3. And you're not going to add any more than that. If you wanted, you could add another 2 pi to all of those angles, but then you'll be too far out. You'll be beyond 4 pi. Just keep in mind 4 pi, you could always express as like 12 pi over 3 if you wanted to have something more to relate to. Okay, so there's our 4 angles, and we're done the question. But it's quite amazing how one simple trigonometry question can wind up getting so many different answers, because we first have to split into quadrants, and then we have to think about coterminal angles. So I'm a really big fan of splitting it into the quadrants, getting those single rotation angles, and then adding 2 pi as many times as we need. Okay, so let's do B. I'm going to switch colors here for showing this differently, so we'll do question B. So in this case, I'm going to just move down a little bit. You don't see a degree symbol anywhere. You also see pi's in the domain restriction, so this is definitely a radian question as well. We see that we have negative 0.45, and there's no way that is special, so we're going to have to use a calculator. So for solving cosine theta equals negative 0.45, what we're going to do is we're going to go theta, and instead of using a special angle, we're going to just use the calculator. So we're going to type in inverse cos of positive 0.45, and in one of the last videos I mentioned that I am a big fan of ignoring that positive sign when I'm doing trigonometry. I think it makes it a lot easier to not do it. One thing I'll just need is I'll need to bust out my calculator. So because we're talking about radians, I gotta make sure it's in the right mode, and it's in radian mode, so we're good. Now I'm going to go second cosine, and I am going to type in 0.45. So when I do this, I go equals, and I get 1.100. So that is my reference angle. I should have wrote reference up there. So 1.104 is probably good enough. So that's my reference angle. So just keeping in mind, 1 radian is about 57 degrees, so 1.1 is about just a little over 60 degrees. So sort of, if I'm going to draw myself the picture here, a 60-degree angle. Now keep in mind, that negative sign there tells us cosine is negative in quadrants 2 and quadrants 3. So what we've got here is we've got a quadrant 2 and a quadrant 3 angle and a reference angle of about 1.104 radians. So what we do is now we're going to go, okay, well, in quadrant 2, my angle, my standard position angle, as always, is pi minus the reference angle. And in quadrant 4, whoops, sorry, 3. In quadrant 3, it's always pi plus the reference angle, because we're going that much further than it. Now, you might be going, okay, well, we can't actually add that, because if you've noticed the domain restriction, we cannot go further than pi. So there's 2 ways you can go about getting that quadrant 3 angle. You can still solve it the way I've written it, where you go 2 pi plus theta reference, but that's too far. You'd actually wind up subtracting 2 pi from it. Or you can use the formula that we had from the previous video, where you work out this formula for a negative angle. And in that case, what you would do is, and if you forget the formula, and by the way, I forget them all the time, so I have to work them out. You think about it this way. You would go negative pi, but then you back up positive reference angle. So it would be negative pi, and then you'd plus the reference angle. You could have just taken what I had written previously and stuck a negative sign with brackets around it, but I like to do it this way. And again, I don't remember formulas very well. I'm too old and dumb, so I have to be able to work it out every time. Okay, so quadrant 2, the pi minus 1.104 is going to give us, and okay, this is where calculator I could probably estimate it, but I'll just work it out this way. So I go pi minus the answer, and I get myself 2.3 or 2.0375, whatever. I'm going to round this to about 2.04. That seems reasonable. Okay, so 2.04 radians. And then I can figure out my other angle by going negative pi. Now, I just realized, I mean, I can type this all in, but guess what? It's there's a symmetry to this problem. I can guarantee it's going to be equal to negative 2.04, but you know, we might as well just see if everything works out. So there we go. So it's negative 2.04. So I mean, the calculation I actually did was this, but we wound up getting this here. And again, the reason why I like to draw these pictures so much is because when you can visualize it, you can see that this angle here and this angle here are the same angle, except the bottom one is the negative version of it. Okay, so my two answers would be 2.04 and negative 2.04. And if you'd like to check your work, especially for this question, I can go and I can just go cosine of 2.04, and when I push equals, I expect I should get 0.45 negative. Close enough, and again, because my rounding sucked, I'm not getting the exact value, and if I do that, I should also get negative 0.45. Cool beans. Okay, so that's it, right? We better just double check our domain restriction, negative pi to positive pi. This is less than positive pi, and this is greater than negative pi, so everything checks out. Life's good. Okay, so that is the little video there. I hope you appreciated Ice Cube rapping for you. He really made my day, and I hope he made yours. Okay, so make sure you can do all this stuff, and if you can't, more practice might be needed. Thanks for watching.